cloud. Okay.
Okay, welcome to the, what is this, August 23rd, 2022 session of
22nd, I think, Dave. Tomorrow's
Well,
23rd. Yeah.
23rd UTC.
Okay, UTC, right. Yeah, I'm thinking of election day here in New York tomorrow.
Okay. And welcome. And for this week, I've been mostly working on my computers, getting them all back running properly, and getting some hard disks installed. I have old hard disks that I need to read and had to be able to get those into the computers. So did that, got my Discone up, and that was a fun little project. Took me a couple months to make it, but finally got it out in the yard and I'm using it now. And that's about it for me. So next on the list, we have Nathaniel, W2NF. Go ahead, Nathaniel.
Thanks, Dave. I've mostly been just trying to work on things at the house and write this National Academy's white paper. As I was saying, I tend to struggle at the beginning of writing and then eventually it comes through. So it's starting to come through, but it is challenging for me. So yeah. I'm working on it. Yeah. Back to net.
Very good. Well, keep working. Next on the list is Bill in 8ET. Go ahead, Bill.
Yeah, okay, not too much to report here today. I spent a couple hours in a dentist chair this morning and walked out of there after writing him a check for almost $4,000. So I guess I feel a lot better now. My teeth are starting to come back together, and one of these days I'll get my grape turned back on. I turned it off when I took off on vacation and didn't realize I didn't turn it back on when I came in and turned my equipment back on after coming back from vacation, and the grape is still sitting here very dark. So I'll get that on the next couple of days to make sure it still works. And that's about it from here.
Well, very good. And I'm glad you got your teeth fixed. So anyway, next on the list is Bill, AB4EJ. Go ahead, Bill.
Well, thanks, Dave. Well, the biggest thing in my week was the Huntsville Ham Fest. I did give a presentation there in which we talked about the machine learning project as well as the personal space for the station. So trying to get the message out there. And at the Ham Fest, I found a new product which I find quite useful. There's a company out of Raleigh, North Carolina, making something called a phase dock system, which it's a series of very nice, they call it a breadboarding kit, but it's like breadboarding on steroids because it's all these things you can snap together, and it makes it possible for you to put a massive junk that's on your table, like a grape with the power supply and the disk drive and a preamp and all this stuff just scattered around in cables, all into one beautiful enclosure. Just take 2 seconds and let you see it here. This is my version 1 grape now, and it's nice enough. Everything is bolted together and won't fall apart. So my plan is to take this to the digital communication conference and let people see what a grape can look like. And you know, they make them in all kinds of different sizes, and so I believe you could probably design an approach to put one of the tangerines in this thing. And the one I just showed you also has the Adafruit GPS as well as a magnetometer in it all running. So it came together quite nicely. So anyway, I do recommend it. So you get a chance to see it at DCC if you come.
Well, very good. You done?
Yeah, back to net.
Okay. Next on the list is one of the two Dave Wittens, KD0EAG. Go ahead, Dave. No mic. You're muted.
He said in the chat he doesn't have audio.
Oh, okay. Well,
Here,
he's-
maybe I got it.
Now you
Just
Oh,
do.
there you go.
Just using a little tablet here. Yeah, my computers, can you hear me now?
Yes.
Okay. Yeah, none of my computer, I seem to be in the focus of a death ray or something from outer space. And all computers here are somewhat haywire. But anyway, yeah, here I am. And I spent my day gnashing my teeth trying to build a new computer. The weekend, I apologize to anyone. The web server on the Linode instance was down because I upgraded everything, and there was some SSL thing that had to be didn't work, and so I put in a new web server and a bunch of other things, and I believe the data uploads were working fine all along, but I upgraded everything to a new Ubuntu kernel, and so we should be good for a while. So hopefully that's under control for now. Do check your data. Everybody should kind of have a look at it, make sure it looks like it's getting uploaded. Let me know if there's any problem, but I believe I got things fixed. That's it for me.
Fine business. And luckily, because of your system, using rsync, the local computers running the magnetometer can store stuff till the server comes back.
Yeah, if it drops out, if the connection drops out, it just picks it up on the next go round,
Yep.
which might be later in the day or the next day or something like that. So, to the best of my knowledge, everything is more or less as always. But I'd sure want to know about it quick if it's not.
Okay.
Thank you.
Next on the list is Jules, K2 KGJ. Go ahead, Jules.
Thanks, Dave. Good evening to everyone on the net. Not a lot to report this week. I've been started to take some photos for assembly instructions for the hardware paper that we're doing for the magnetometer mounting, and it's coming along. Other than that, did a little bit this week with trying to get a SDR Play RSP2 up and running on a dedicated Pi to listen to 245 megahertz noise, the check solar noise bursts. Now I have to make an antenna for that, but that's about it here for this week. Go ahead.
Well, it sounds productive. Next on the list is, let's see, Dave McGaw, N1 HAC. Go ahead, David.
Good evening to the net. Been intrigued by watching the CMEs go past, some interacting, some not. I expect we'll get some very interesting data out of those. And been listening for the burbles on WWV, both ends. Sometimes you hear it on 2.5, sometimes on 20. And then continuing to work on the radio quiet power system for Antarctica, making some progress there, we hope. And oh, and I just interesting, all this NAS study is really getting everybody jumping and energized, because our AeroVista CubeSat that we're working on now, they're talking about doing a paper on that as well. So yeah, I guess it's a good thing. It's like well, I don't know. I guess it's like shoot. Anyway, it's good every 10 years we get everybody thinking about, oh, what are we really doing?
Yes.
And getting ourselves re-excited about it, which is
Yes.
great. Anyway, Back to net.
Very good. So next on the list is Human Kim, KD2 MCR. Go ahead, Human.
Yep, good evening, everyone. Just like Nathaniel, I've been working also on white paper for decadal survey. Now it's been extended again. So we have just started working on the paper, Hardware X, to put everything together about the magnetometer work. So that's another to-do. That's another item that is on my to-do list. Other than that, there's nothing specific to report. Back to the net.
Okay. Next on the list is Jay Schwartz, WB8. Wait, SBI.
Whiskey Bravo 8 Sierra Bravo India.
Well, I was saying it, and then when you turned your screen on, your name jumped in the list.
Hi, everybody. Been absent here for a little while due to schedule conflicts, trying to get back into things. Nothing specific to report here. Hoping to be able to make it in person to the DCC, and if not, we'll be joining virtually. Other than that, I've been wrapped up with Society of Automotive Engineers cybersecurity issues, so that's been keeping me occupied here. Other than that, nothing specific to report. Hope everybody is safe and well, and see you later on down the log.
Okay. Well, next on the list is James KG4 DSG. Go ahead,
Yeah.
James.
Hey, Dave and the group. Dave, I sent you a message in the chat. We can talk about that later. Not much going on here. Watch the Artemis 1 rollout on a replay in fast forward mode because real time it doesn't move. The launch is scheduled for next Monday. Maybe we'll have something to report.
Okay.
That's it.
Let's see. Where am I here? Joe is next. Joe Hobart. W7 LUX. Go ahead.
Good evening, all. Missed last week. Zoom changed something, and my system just wouldn't work anymore. It brings up the video, and then or the meeting, I mean, and then poof, goes bad. So I had to change computers here. Kind of wet weather here. Nothing like what they're getting in the Central South, but we're getting our share. Got 2.5 inches over 2 days. That was a bit much. Grape has been grinding along, and kind of interesting because I got a cheap little SDR radio from China, and at one point it was hearing WWV on 2.5, 5, 10, 15, 20, and 25 megahertz. I think there may be a front end, front end filtering needed to make that work properly. And then Jonathan sent a MP3 file of whistlers, and I'm sorry, but I just don't hear anything. And I suspect that umpteen years of listening to loud noises in the Navy and local lightning strikes have sufficiently upset my hearing to where I just don't hear whistlers anymore. That really bothers me. Just wonder if anybody else listened to that recording and could actually hear whistles. All I hear are a few thumps and a few clicks. Anyway, thanks, Dave.
Same thing I heard.
Oh,
I didn't
okay.
either.
That's interesting. Thanks, Dave.
Yeah, okay. Next on the list is Jonathan, KC3EEY. Go ahead, Jonathan.
Hi, everybody. I'm still in the process of moving, so I didn't get a chance to work on a lot of stuff. But so the post on the Hamside group about the Echo Train event. The whistler was actually pretty weak. The initial whistler was pretty weak, and the echoes were weaker and weaker as they went on. They can be very hard to hear. Sometimes it's better to listen with headphones or your ear directly to the loudspeaker. But I was able to detect 11 or 12 echoes, at least listening with my headphones. I also kind of know what to listen for. So if you don't know what you're listening for, then sometimes those quiet signals could be hard to discern. But that was quite an exciting event. The causative sphere came from a lightning stroke in the North Atlantic, and it had a pretty big footprint. Probably best heard in Greenland, if there was any VLF receivers up there. Also, I spoke with Trimble support, 2 application engineers. One of them that actually worked on the Trimble mag mount antenna many years ago, about the pulse per second issue, and I received some insight from one of the application engineers. Now, so with the Res SMT 360, as with others, there are 2 modes. There's GPS timing mode, and then there is local oscillator, or a local oscillator mode, or internal oscillator mode, I should say. The issue seems to stem from the fact that I have the GPS receiver set to output a PPS, even though it does not have a good fix. It does not have a timing solution. It'll output a pulse per second signal based on the internal oscillator. And so what's happening is when the pulse width actually jitters, what I'm seeing the difference between the internal oscillator and the actual GPS timing solution, and it tends to be that around 1.5 milliseconds, and that's what's actually going on, because by default, if it does not have a proper timing solution, it will not output a pulse per second signal. That's by default, and since I have it set to output anyway, there's that issue when it comes when the reception conditions are marginal and it does not have a timing solution. It'll actually jump between the two, and when your software expects the leading edge of the pulse to be 60 seconds later within a small window, and it's not, that's because the leading edge actually jumped 1.5 milliseconds positive or negative in time. That was the reason why that the software would actually miss it. So the easiest solution would be to set the Trimble not to output a pulse per second signal when it does not have a timing solution, and implement a holdover mode in the software, which there already is, and also to use a proper outdoor timing antenna, because the timing antenna has much better filters than the mini mag that I was using. So that was a pretty interesting and it was interesting and enlightening, and kind of makes me curious about what the U-Blox devices do in that same situation. That I would like to eventually test. Lastly, the author of VLFRX Tools posted an information an information page on his website describing his VLF receivers, all the work that he's done, exactly how his systems are set up, and all the signal analysis and everything like that. I could just breeze through here. So this is that website. I'll post the link in the chat if anyone is if anyone is interested. So he has his schematics for his preamp and line driver, for his E-field receiver and pictures, for his H-field receiver, pictures as well. So if you want to build what he has, you can definitely do this. It describes his cabling, his feed line, and the power and signal on a Cat5. It describes his A to D conversion. He's using the Behringer UMC 404 HD to capture the VLF audio, and he talks about his signal processing using VLFRX tools, BT time for time stamping, calibration. He has some example signals. These are actually really nice recordings. Whistlers, his recording of SAC this past Christmas Eve. Some nice analysis with spherics, amateur signals, military signals, ZEVs and Alpha F1, and he has some miscellaneous items too, and he even has a picture of his office. Very, very interesting. Lots of really good work here. So I was very happy that he documented all this. That is all I have. Back to the net.
Okay, well, thank you. And next on the list would be Noel, WB0BGI. Go ahead, Noel.
Thanks, Dave and the net. Been out at Boy Scout camp for the last few weeks and back here. Has the address or something changed with picomation.net, or is that still the same?
That is the problem that Dave mentioned over the weekend.
You may not have heard me say that I did an upgrade on the server to bring it up to a reasonably secure kernel. And in the process, I ran into some difficulty with the SSL certificates. I reinstalled the web server and rearranged things. I believe it should be working now.
I can't see it. I can't see it from here. So I haven't gone to see whether my data transfer is working or not, but I can't see the list of the directory from.
I have logged into it this afternoon, and it appears to be working fine.
Is the number changed? Has the IP number changed?
Nope.
Okay.
It may just be your web server needs to be refreshed.
Okay, well, I'll battle that some other time. Yeah, still running the magnetometers. All the magnetometer data is still flowing onto that. If it is, I guess it is.
Yeah, I believe it is.
Yeah, and so the only The only change, the only question I have is anybody else coming to the AMSAT conference here in Minnesota in October? I know that you guys are going to do the digital one, but is anybody else coming to AMSAT? That'll be in Bloomington in.
Yeah, I'm hoping to be able to make that myself.
Okay, good.
How far from the Twin Cities is that? Did you fly to Bloomington or fly to the Twin Cities?
You can fall out of the airplane and you'll end up in the parking lot of the hotel.
What, at the Twin Cities?
Well, it's right. Yeah, the planes fly right over the hotel that they're having the conference at.
Minneapolis, St. Paul.
Right.
Yeah, in the Minneapolis airport in Bloomington, technically.
Yeah. The airport's in Bloomington. That's just on the south edge of Minneapolis.
Yeah,
So-
about 20 years ago, I spent the summer in Owatonna.
Oh,
Working down there.
in Owatonna.
Yeah, I had a good time.
That's how we tell people that aren't from Minnesota. We try to pronounce all these names. You can do the same thing in Connecticut. Yeah, so that's about it. If you're coming, that would be great, Jay. Get a chance to eyeball QSO, and that should be interesting. This.
As long as I don't have to deal with the state bird of Minnesota.
Oh, well, they'll be dead by then.
Not that.
Yeah, good.
Actually, we had a really easy summer for mosquitoes this year. It was wet at the beginning, but it dries out now. Now we just have too many damn politicians.
All right, that's out of scope for this group.
Yeah. That's on the other side of the record. So that's it. Thank you, David.
Okay. Next on the list is Tom, N5EG. Go ahead, Tom.
Okay, good evening, Dave and the group. I sent the current build of the FPGA code to Kwong. He was able to get it to completely build. So he was happy about that. I spent the week trying to figure out how to start modifying Verilog code. The first attempt to put the I/O drivers onto the I2C interfaces. I copied the code out of the handbook on how to do that and have failed absolutely miserably in trying to get any of that to compile in Verilog. And it's, I think, some inexperience in Verilog on my part. I've never done a Verilog project before, and some missing information perhaps from Quartus. The signals, you have to have fully qualified signal names because there's 5 I2C controllers in the FPGA for our project. And so you have to have a module name, an instance name, a conduit name, and a signal name. There are 4 visualization tools in Quartus, and as far as I can tell, each of them uses different formatting for the text string on how to fully qualify the signal name. So they're all different. And I've tried all 4 ways, but none of those have worked. And they all differ from the way the Verilog standard says to do it. The Quartus error code is equivalent to the first line of your code, something went wrong. And that's pretty much the extent of the error message. So I've tried tracking that down, and everybody that I could find on Google searching has the exact same error message for all their totally, completely different errors. And so I think I'm in the point now where I need to find somebody who actually knows what they're doing, who can talk me through getting started in this process. But other than that, some successes and some groping around in the Verilog dark here, but we'll get it. Back to the group.
Okay, well, have I missed anybody at this point? I think I've called on everybody. So hearing nothing, I'm going to say we're open for general discussion.
Sounds good. So I guess one message for Jonathan. I got the new hard drives in, and what I'm doing right now is I'm copying the chirp sounder data to this 14 terabyte hard drive that I just got. And then once I do that, I'm going to give that hard drive to Simmel, and she's going to give me back a 10 terabyte hard drive. And I will use that, set that up so that you can copy VLF data onto that.
That's awesome. Okay. That will be, we could do that through your Ubuntu machine.
Yeah, I might actually set it up. I have a little NAS here that
Yeah.
also it actually runs a version of Linux on it. I might set it up through that. That way the Ubuntu machine's you're not dependent on my Ubuntu machine.
Okay. Okay. Well,
We'll work something out.
yeah. That'll work out then, because I could do like well, once I see it, I'll
yeah, either that or through a Raspberry Pi I have running here. But I'll do one of those ways.
Okay, that'll work.
Yeah. Is there a reason you need a strong Ubuntu machine? You were going to do like additional processing on it, right?
Oh yeah. Well, I don't really need anything really too major.
Yeah.
Something better than a Raspberry Pi 3, but.
Well, I have a couple of Ubuntu or a couple of Linux boxes lying around that are in various states of repair or not repair, but it'd be really nice to get them up and running again. I think one of the problems is I tried upgrading the RAM in them a couple of years ago, and I used cheap RAM, and I think the cheap RAM's bad. So I'm wondering if I put the OEM RAM back in, if it'll come to life. But if that's the case, then you could have like a nice Core i7 machine that is just dedicated to whatever sort of VLF tasks you're planning on doing. I think that would be ideal.
Yeah. That'll work great. I mean, we could try with your NAS, but yeah, that'll work.
Yeah, I like to try to keep the different machines separate for the different tasks, so that if one machine goes down, it doesn't take everything down. And and conversely, like I like there's less likelihood of one system causing another system a problem, especially when you really need it. Like I like my Ubuntu machine right now to just be there for me doing data analysis, and I don't want anything else to possibly interfere with that. So if I could set up a separate machine for that. So there's one sitting right behind me that if we just maybe if I put the OEM RAM back in, it'll work, and then it'll be a really good machine for that. So we'll see.
Yeah. All right.
We'll work on it.
Sounds good.
And did you get my message for Thursday?
Yes, I did.
Wonderful.
I'm in the process of moving. I will more than likely be able to go, and if I cannot, then I will just let you know.
Sounds wonderful.
And thank you for the invite.
You're welcome. And for everyone else, I'm having a little research barbecue for my students and people who've participated in research over the past summer. So you're all invited. If you're in the Pennsylvania area, feel free to stop by Thursday evening around 4 or 5 p.m. for a hamburger. Hyoman and Dave and Jules, where did we leave off with the paper discussion?
Let's see. We've been doing emails. Have you been reading all of those?
I read them up through this morning. I didn't get to read the ones that happened during the day today.
Yeah, Hillman was asking me about something of one of the characteristics of the RM3100 that was in a paper published by one of the authors, one of the co-authors of the original Rigoli paper on the RM3100. There was just a clarification there. Other than that, we decided that it would be good to give a essentially history of the hardware development.
Mm-hmm.
And the experiments that Dave ran, and also the original design of an idea for the differential I2C,
Mm-hmm.
and then the additional stuff that I was able to add to that with the tests out at 400 feet and so on.
Okay.
So that'll be included as an introduction, and what we'll use for the actual available hardware today will be whatever is released by Tapper for the board and the BOM and so on and so forth.
Okay, that sounds perfect.
Yeah, and then I've been working on, well, you've kept up with that, I think, during the week. I sent out a couple of emails regarding mounting of the waterproof connector and the cap, or the
Right.
plug, the spigot rather, and I'm in the middle of doing photos on that with step-by-step showing how that's assembled, which should be pretty easy. Right now, I'm just waiting for a replacement file. My daughter borrowed my my half round, and I need a replacement for that. So
Okay. That all sounds really good.
I don't know, Hillman, did you have anything else to add?
No, yeah, it's just that, yeah, I mean, I happened to find a paper that was written by someone who seems to be, I guess, either postdoc or student of Mark Moldwin. So I actually introduced that paper to, the magnetometer people here. And I was just asking for some clarification, in terms of like their functionality and specification. But yeah, Jules, thanks. Yeah, thank you. I'm still trying to understand the mechanism of averaging, but I'll get back to you on that later.
Okay, it's
But
actually
nothing more than
yeah.
just clarification.
It's actually very simple. It's basically, if you consider that you've got an accumulator that will sum a bunch of individual readings, but do it in such a way that you don't look at the readings until that accumulator is filled with whatever the count was in the 0x0A register. And that's what you're reading from the magnetometer. And so that is a single reading, actually, excuse me, the sum of a multiplicity of readings taken all at one shot just by requiring the magnetometer to take a single reading. By putting a non-zero number in the 0x0A register, it actually takes multiple readings. Let's say if you put 20 or 30 in there, it'll take 30 readings, sum of all of those into the output register. And when you actually read the results, that's what you're reading. So in order to get the correct gain factor, you have to correct for that additional 30. But basically, it's a very simple process. It's just an automated thing within the RM3100 ASIC that was originally designed for test and development by the engineering crew, which was, it's not actually advertised as a feature, but Dave and I were able to get into PNI and probe some of their texts and find out what it actually was used for. And then I did some measurements on it to indeed indicate that it does take serial measurements one right after the other. So you give it a command to take a single measurement. And if you look at the I2C bus, you'll see a variety. You'll see all the measurements occurring before you actually get the final result.
Okay. So in addition to those, like, technical hardware internal design, can we also add some testing procedures? How did we come up with that number? For example, the resolution of 6-ish nanotesla, that kind of stuff. I think that'll be also interesting to put that. I think that's kind of essential to put that information there.
Yeah, that number, let's say, because at the best resolution I've seen, using both the averaging at a cycle count of, let's say, 400, and the sliding average window after we get all the 1 second data. The best I've seen is about 2.5 nanoteslas in terms of resolution. So that, that's essentially empirically determined looking at actual data. In terms of test, the only way to really do that, and we discussed that before, is to take the 3-shell shield, basically the mu metal shield, put a source, an axial source inside of that, so you can actually know what the value of the field is at the axis, and then just dither that field a bit to see what the magnetometer can pick up. I've done a little bit of that using a simpler shield, and it is possible, but one of us would have to buy. I think you have a shield already, but I was going to invest some money in one of the three component shields with full caps on either end that can take an internal source.
Okay. Yeah, we can.
But all those numbers that we have so far were empirically determined from data gathered in the field.
Okay. All right. So yeah, Nathaniel, I mean, in summary, it's moving along. I am not so familiar with all these like technical details, so that's something that I'm relying on. That's I'm still waiting. Relying on these folks to give us all these detailed information, technical information.
I think that sounds very good.
Mm-hmm.
Thank you, everyone, for working on this.
So, Nathaniel, I just, as you saw in the template was given by the journal.
That's right.
Like there's no room for mentioning any like scientific background, why we do this kind of stuff. I guess it's very engineering oriented, I think.
It is very engineering oriented, but I do think there is some space to provide some science background. In fact, I remember when the GRAPE 1 paper was written, the reviewers actually, I think they came back asking for some more science background.
Oh, okay.
So I think you would put it, I can look at the, let me bring the template up right now.
Yeah, where was it provided in the GRAPE?
Here, I'll share my screen and we can figure this out. So, so this would be the hardware X ham-sci magnetometer one. And then should be able to switch to PDF.
Yeah. I'm sure everybody's fluent in LaTeX.
Yes. We all have our things.
Yes.
Let's see. And then, okay, so hardware and context. So right here, hardware and context, for a short description of the hardware and provide context. Well, I would think that you would include some of the science applications right here under the hardware and context section, because it wouldn't make any sense to have this thing exist if you didn't have the science application.
Right.
So I think right at the beginning it goes in, and then build instructions, and then again, let's see, possibly under maybe under validation and characterization as well, because you're probably going to be showing some of those cases where you might be comparing it with observations from, say, like the intermagnet professional installations. I know we've seen some of those before, and when you're doing those characterizations or that validation and comparison, you might provide some context as to why you're looking at those particular features.
What I was thinking of too was to include a reference to the Rigoli paper, which gives a very, very good rundown of the capability of the unit, noise level, et cetera, and its operational function. And that's really kind of the defining paper for it.
So I would think that would go in that hardware and context section, which to me, this is kind of like the introduction. We can look at what the GRAPE 1 paper did as well, which incidentally, I've been trying to keep track of peer-reviewed papers that are ham-sci related. If you go to hamsci.org/peer review, I just keep a running list of these things. So, and we've been seeing more peer-reviewed publications using ham radio data come out like on a weekly basis recently. Another one just came out this morning, so it's very exciting. A lot of people are using these things. But let's see. I'm just gonna download the PDF because I like how that works better. View, page display. Let's see. Zoom to page level. So yeah, here you can see their hardware and context. They spend quite a bit of time,
Mhm.
you know, going over the motivation for it. And she even, they have Christina's figure showing the cartoon of the Doppler shift there. They include the block diagram of the personal space weather station. I don't think you need to include that, but I do think that first section is where you can provide a lot of that scientific background and motivation.
In terms of motivation, why do we need it? I think, Herman, you could start that off, and then basically when you just say why, and here's what we need to do, and then we can run into the, well, here's how we're going to do it at a low cost, basically in a context that fits into the citizen science kind of operation.
Yeah, I'm sorry, my internet cut out for a minute. Can you repeat like the last minute of what you said?
Oh, but yeah, I was saying that for that hardware and context, basically to start out with, why do we need this device?
Right.
Then human can provide that information.
Yes.
As justification for then, okay, here's how we did it.
Yes.
And then this is the device we chose for these reasons, and, you know, work down from there. But basically to start out with why.
Yes.
And yeah, okay, sure.
Yeah.
And does it meet the requirement for our scientific investigation? Like, you know, is this sufficient enough to perform like scientific investigation?
Right, and you originally, Human, stated something that you felt something on the order of 5 nanoteslas, I believe,
right,
would be adequate for looking at least some of the detail we'd like to see in
right.
the space weather program.
Right.
So you could, you know, you can kind of reiterate that, and then we'll follow up with, well, here's a device that can produce that. And here's why we chose it, and so on and so forth.
So,
may I make a suggestion? I think it's important that you talk about the trade-off between lots of less expensive sensors versus a few highly calibrated sensors.
In what respect, Dave? I mean,
in that the fact that the overall data set might be as valuable with a less precise but higher frequency number of sensors.
no, they're more spatial sampling points.
Yes.
Yeah. Yeah, that can certainly be mentioned as well. Sure.
Because that's the advantage of our approach versus the other approach.
Right. Well, in fact, I mean, the multiplicity of relatively low cost and possibly less precise sensors is kind of the rationale for all the rest of this stuff in the Space Weather Project also.
Right. Correct.
So this is how that fits in. Yeah.
Yes.
Right.
And you can see they also have, down under operations, they have some figures, output figures, which you have a chance to maybe talk about some science if you pick the figure appropriately.
Sure.
Same thing under validation and characterization.
Yeah, we've got some things that show for CME passage, for example, stuff of that sort. Yeah.
Right. Right. Yeah, I think that's good. Yeah, thank you.
Okay, so we just have to keep on keeping on.
That's right. Just like I have to keep doing for my National Academies paper, which I can show you.
Yes.
So this is kind of, I can show you where I am with that too. If I go back to my overleaf, speaking of, switch this over here to that. Redirect to editor. So let's see. So here's kind of my outline, an introduction, my outline and table of contents so far. So the introduction is, what is the amateur radio community and kind of what is its history in terms of doing science and what are some of its capabilities. And then I'm going to go through, or I'm starting to go through, what are the mechanisms that amateur radio can be used to remote sense the ionosphere? What are some of the observation networks that already exist? So reverse speaking network, PSK reporter, WhisperNet. And I'm using some of my figures from my papers to illustrate some of that. And then I cite a number of these other papers that have also been published recently that use these things. Talk about purpose-built citizen science instrumentation. So this idea of this personal space weather station. So these are instruments that are specifically being built for science, not just for amateur radio use. And then talk about some ideas about how amateur radio might be able to advance heliophysics. So the idea that we can increase both spatial and temporal sampling. We might be able to localize space weather impacts, because right now, we're very used to using parameters such as KP. Everyone here is used to the KP index, and that's one number that represents the entire globe.
Right.
And perhaps that's not the right way to go about it. And so this is moving back to the idea that, maybe we could narrow space weather measurements down to a more localized area on Earth.
Mm-hmm.
Steve Kepler sent me some information about, using amateur radio to study sporadic E. So I might put that in there. Operations to research to operations, this idea that, or you could say like research to operations, the idea that we're using the amateur radio as a research thing right now, but perhaps the goal would be to go from research to actually making these data sets available to help provide an operational product for predicting propagation and helping to improve understanding of propagation on a nowcasting and forecasting basis for both amateurs and other users of HF communications. And then I have a section that would be on fostering amateur and professional collaboration. So talk about HAMSci and basically try to talk about some of these things that, how do you get the amateur community and the professional community to work together? And I think, we've had HAMSci now for over about 6 years. We've run the HAMSci workshop and we've done very well with community engagement. But I think some of the other things, we're still trying to work out, like this idea of co-engineering and co-authorship. We're trying to figure out how is the right way, like what's the right balance for having volunteers actually be co-authors and write papers versus the people who are leading the projects. Same thing with the engineering. How do we strike the right balance of making sure the people who are volunteering get the proper credit they're supposed to get and not be overworked and get something valuable out of it, while also like having the professionals be able to keep the project moving on time and in what, do what they promise to do. So how do we give back to the amateur radio community? How do we provide education and training? So these are the ideas that I'm trying to work into the paper right now.
Yeah. Suggestion, Nathaniel.
Yes.
On 3.4.
Uh-huh.
That title, I would go back to just research operations feedback.
Okay.
Or feedback loop.
The thing is, there's a buzzword. They actually use this buzzword in like the decadal survey call, where they talk about research to operations and operations to research. So even the NASA grant that we have funded right now that I'm on with Bill Engelke is it's a NASA grant called SWO2R, which is Space Weather Operations to Research. So this is actually a term title. It's an official term, yeah.
Yeah, it would almost be better as a graphic, having basically operations with an arrows circling around from one to the other. So it's the continuous feedback loop.
It just sounds very redundant if somebody's reading it. It
Yeah.
doesn't have that background.
Yeah. So I mean, if we national,
You can refer to the place where that comes from.
yeah,
Hmm.
I think there's this national space weather action plan that I think it might actually come from. And we've gotten a couple of white research to operations. Yeah, it's in here somewhere.
Yep.
So
Well, it's just a suggestion. You do it.
Yeah.
You're the one writing it.
I know. So I appreciate the suggestion. I've been trying to take into account people's suggestions. So yeah, now I'm trying to just get it all.
It is a
going.
feedback loop that you're describing.
Yeah.
Yes. Yes. I'm trying to illustrate, you know, I'm trying to include some pictures too. Students working with modest stations and longtime amateurs working with very large stations.
Your picture reminded me of something. I still have had no slides from either Diego or Veronica.
Okay, well, I will go back and
That's
work on
from
from Hamvention.
Hamvention.
Okay, I'm supposed
I
to
mean,
see.
I have the recordings of them, but
You just don't have the slides.
yes.
All right, I'm gonna see. I will see Diego on a Telecon tomorrow morning, and then
If they want to have something online that they can cite, or
yeah, no, that would be good. So I will remind them.
okay.
So yeah, so that's where I'm going with this right now.
Very good.
Okay.
Well, we're at the hour.
Okay.
We
So-
are. Oh, before we go, I will just give one more hamsci.org/peer review. Point out one more thing. I've sent a number of these things out on the website so far. But Catherine Mitchell's group, they just came out with a systematic study of 7 megahertz gray line propagation using amateur radio beacon signals. And so that's just been published. And if you look at that, you'll see a lot of names that you know, including Catherine Mitchell and Ben Vitfleet, Gary Bust, maybe some of you know, and Bill Lyles and Gwyn Griffiths. So this is a very interesting article to take a look at.
Yeah.
And there are a few other peer-reviewed papers that just came out. I should put those up here as well. I don't think I have them posted yet, but I'll work on that. So, and then starting next Thursday, we're going to start having Thursday at 4 p.m. Eastern telecons, starting on September 1st. So not this Thursday, but a week from there. This is going to replace the bi-weekly HamSci telecon, and this is specifically going to be for planning the solar eclipse QSO parties.
Okay.
Okay, great.
Very good.
Thank you.
Well,
all right, I guess we'll say I'll stop the
I-
recording and I'll say 73.
turn off the recording, and I assume anybody that wants to stay and talk, they can.